Okay, in this lesson we're going to take a look at rational expressions. And in the past, you may have learned what a rational number is, so let's just do a review of that before we take a look at rational expressions. So a rational number is a number that can be written as a fraction, a over b, where a and b are both integers and b does not equal to 0. So a number like 3 can be written as 3 over 1, and the top and bottom are both integers. A number like negative 1/2 is already written as a fraction where the top and bottom are both integers. Another rational number might be something like the square root of 4, which really is 2, which is 2 over 1. 0.1 is okay because that's really 1/10, so it's negative 0.1 because that's really negative 1/10. Whereas a number like the square root of 2 cannot be written as a fraction a over b where these are both integers, and so it's not a rational number. It's called an irrational number for a reason, and same with pi. The decimal place goes on and on and on forever, as does the decimal place for this. It goes on and on and on forever without repeating and without stopping. That's another indication that you cannot write it as a fraction with an integer on the numerator and an integer on the denominator. Okay, let's take a look at rational expressions and how similar they are to these sorts of numbers. So a rational expression, it's not a number, it's an algebraic expression that can be written as a fraction. But now instead of just numbers, a and b are pieces of algebra called polynomials. And we still have that condition that b can't be 0. In fact, any value that we put into this rational expression that makes b equal or makes the denominator equal to 0 is called an undefined value, or we sometimes say that's a restriction. And this is easiest to see through an example. So rational expression, and let's just take a look at these restrictions. So here's an example. If I have 2x plus 5 over x minus 1, I have an algebra expression. I have a polynomial on the top and a polynomial on the bottom. And I have a restriction to this. And the restriction for this one is whenever this bottom part, the denominator, is equal to 0. We don't want it to be equal to 0, so to find out when it's equal to 0, make it equal to 0. Just set it equal to 0 and solve this little piece of algebra by adding 1 to both sides. So x equals 1 is the restriction on the domain. In fact, often we say the only value that it cannot be is x cannot be equal to 1. Another way that rational expressions are like fractions is that they can be reduced, very similar to how we reduce fractions. So let's take a look at that. So when we have fractions like 3 over 6, we can cancel out a common factor, divide by 3 on the top and divide by 3 on the bottom, and we can make an equivalent fraction. And we can do the exact same thing with rational expressions. Let's just fix that sentence there. So for example, if I start off with 2x plus 4 over 4x minus 2, there is a way of making this more simplified, and the step that I have to do is I need to factor. So I'm going to factor the numerator, take out a 2, and factor the denominator, also take out a 2, and I can now see there's a common factor. That's what I'm canceling. So there's the common factor that I cancel out, and my final solution is x plus 2 over 2x minus 1. The key step in this is you must factor these. Let's take a look at a couple more examples. The next one being x minus 3 over x squared minus 9. So the top, the numerator doesn't factor, but the denominator sure does. It's x plus 3 and x minus 3, and you can cancel out entire pieces of algebra. And when you do that, on the numerator I have 1, and on the denominator I have x plus 3. And a little side note on this, for this one, the restrictions on this one are easily seen at this step here, and I'll highlight it in black. The denominator here could be equal to 0 if x is equal to -3 from this piece, or if x is equal to +3 from this piece. So just a little aside, sometimes people will look at the final solution and be like, oh, the only restriction is x minus 3. But actually restrictions come from the original equation, and the original equation, once factored, you can see the two restrictions a little easier in that second step. We'll be doing quite a bit of that this homework and in this unit, so thought I would show you that. And of course, we can get much more complicated things. In this case, I have x squared minus x minus 12 over x squared minus 4x, and we need to be able to factor, and to be able to do this relatively quickly, something like this x squared minus x minus 12. So multiply to -12 and add to -1 is -4 and +3, and on the bottom there's a common factor of an x, and left over is x minus 4. And you can see that there's an x minus 4 term in the numerator and the denominator, and so you get x plus 3 over x. The x's cannot cancel because we can only cancel common factors, and factors are things that are multiplied together. So I could cancel this whole piece with this whole piece because they're multiplied. But these are added and subtracted, so I cannot cancel those. Okay, we'll see you in class to have some practice.